How do skyscrapers actually stay standing? When you look at a skyscraper, it almost feels impossible. It is a building with hundreds of thousands, or even millions, of pounds stacked high into the air. It has steel, concrete, glass, elevators, pipes, wires, people, furniture, wind, rain, and gravity all acting on it at the same time. And somehow, it does not fall over. So the real question is not just, how is it tall? The better question is, where do all the forces go? Because a skyscraper is basically a force-moving machine. Every load has to travel through the building and eventually into the ground. That path is called a load path. A load path is the root force takes through a structure. In a skyscraper, the weight from each floor moves into beams. The beams move that weight into columns. The columns move the weight down through the building. Then the foundation spreads that weight into the earth. That is the basic idea behind how tall buildings hold up. The building does not make the force disappear. It guides the force safely downward. The first major force is gravity. Gravity pulls everything down. Engineers divide that weight into two main types. The first is dead load. Dead load means the weight of the building itself. That includes the steel frame, concrete floors, glass, walls, pipes, elevators, and roof. Even when the building is empty, it is already extremely heavy. The second is live load. Live load means weight that changes. People are live load. Furniture is live load. Computers, equipment, water, and supplies are live load. A skyscraper has to hold both. That is why columns are so important. A column is a vertical support. Its main job is to handle compression. Compression means being squeezed. In a tall building, the columns near the bottom are squeezed by all the weight above them. The higher floors push down. The middle floors push down. The lower floors push down. So the bottom of the building has to be extremely strong. The lower columns usually carry much more force than the upper columns. That is why the base of a skyscraper is such a serious engineering problem. But columns alone are not enough. Floors need horizontal support too. That is where beams come in. A beam is a horizontal member that carries load across a space. When a beam holds up a floor, it bends slightly. The top of the beam gets squeezed. That is compression. The bottom of the beam gets stretched. That is tension. Tension means being pulled apart. A good beam has to resist both compression and tension. That is why steel is so useful. Steel is strong when it is squeezed, and it is strong when it is pulled. Concrete is different. Concrete is very strong in compression, but weaker in tension. That is why reinforced concrete has steel rebar inside it. The concrete handles the squeezing. The steel handles the pulling. Together, they make a stronger system. That is one of the biggest ideas in engineering. Do not just ask, what material is strong? Ask, strong against what kind of force? A skyscraper also has to handle shear. Shear is when parts of a structure try to slide past each other. Imagine holding a deck of cards and pushing the top sideways while the bottom stays still. That sliding action is like shear. Wind, earthquakes, uneven loads, and twisting can all create shear forces in a building. And wind is the next huge problem. For a small house, gravity is usually the biggest force engineers worry about. For a skyscraper, wind becomes a major challenge. The taller the building gets, the more wind it catches. Wind pushes sideways. That sideways force is called a lateral load. Lateral means side to side. A skyscraper has to resist vertical loads from gravity and lateral loads from wind at the same time. That is difficult because a tall building acts like a giant lever sticking out of the ground. If wind pushes near the top, the building wants to bend and sway. It can also create a turning force at the base. That turning force is called a moment. The taller the building, the bigger that moment can become. Think about holding a pencil at the bottom. If someone pushes near your hand, it is easy to resist. If someone pushes near the top, the pencil wants to tip much more. That is what wind does to tall buildings. So engineers need systems that keep the skyscraper from tipping, twisting, or swaying too much. One important system is the core. The core is the strong central part of many skyscrapers. It often contains elevators, stairs, bathrooms, mechanical systems, and utility shafts. But structurally, the core acts like the spine of the building. It helps resist bending and twisting. In many modern skyscrapers, the core is made from reinforced concrete. That gives the building a strong, stiff backbone. The floors connect to the core. The outside columns and frame work with the core. Together, they help the building resist gravity and wind. Some skyscrapers also use bracing. Bracing means adding members that make the frame stiffer. Many braces are diagonal. Diagonal braces often create triangles. Triangles are powerful because they hold their shape. A square can shift sideways into a slanted shape. A triangle is much harder to deform. That is why triangles show up in bridges, cranes, towers, roofs, and tall buildings. The triangle helps move force through tension and compression. Some members get pulled. Some members get squeezed. The shape keeps the structure stable. Another system is an outrigger. An outrigger connects the central core to the outside columns. Think of trying to balance with your arms at your sides. Now think of balancing with your arms stretched out. You are harder to tip over. An outrigger does something similar for a skyscraper. It helps the building use its full width to resist sway. The shape of the skyscraper matters too. A simple square tower can catch wind in a strong, rhythmic way. Wind can create swirling patterns around the building. Those swirling patterns can make the building vibrate. So engineers often change the shape. Some skyscrapers taper as they rise. Some have rounded corners. Some have setbacks. Some twist. These shapes are not just for looks. They help break up the wind. If the wind cannot push evenly, the building can move more safely. And that brings us to movement. A skyscraper is not supposed to be perfectly still. Tall buildings are designed to move slightly. They sway in wind. They expand and shrink with temperature changes. They vibrate from machinery, elevators, and people. If a building was completely rigid, it could crack. The goal is not to stop all movement. The goal is to control movement. Engineers want the building to move in safe and comfortable ways. If it sways too much, people inside may feel dizzy or nervous. The building might still be strong, but it would feel unsafe. So some skyscrapers use a tuned mass damper. A tuned mass damper is a heavy weight placed near the top of a building. It moves in the opposite direction of the building's sway. When the building moves one way, the damper moves the other way. That helps absorb energy and reduce motion. Some dampers are giant steel balls. Some are concrete blocks. Some use liquid. The goal is the same. Control sway. Reduce vibration. Make the building feel stable. Finally, none of this matters without the foundation. The foundation is where the building meets the ground. Its job is to spread the load into soil or rock. But not all ground is the same. Some soil is soft. Some soil settles. Some ground has bedrock close to the surface. Some ground needs deep supports. Before a skyscraper is built, engineers study the ground carefully. They drill into it. They take samples. They test the soil and rock. They need to know what the building can safely sit on. Some skyscrapers use a huge mat foundation. That is like a giant concrete slab under the building. It spreads the weight over a large area. Other skyscrapers use piles or caisson. These are deep foundation supports that reach down to stronger soil or bedrock. So the part you see above ground is only part of the engineering. A lot of the work is hidden underground. When you put it all together, a skyscraper is not just a tall stack of floors. It is a carefully designed system. Gravity pulls down, so beams, columns, and foundations create a load path. Wind pushes sideways, so the core, braces, outriggers, and shape resist lateral loads. Materials have strengths and weaknesses, so engineers combine steel and concrete. Movement is unavoidable, so engineers control it. Every part has a job. The columns carry compression. The beams handle bending. The core resists twisting. The braces add stiffness. The foundation spreads the load. The whole building works together to guide force safely into the ground. That is how skyscrapers hold up.